Okay, so this lesson today for solving right triangles should actually be pretty easy. This is something that you did in Algebra 2, and we actually did it a little bit in Geometry too. So what we're doing basically is given some right triangle and given a particular number of measurements or given a side length, and your job is to figure out the rest of the angles, the missing angles, and the rest of the missing side lengths. So that's what it means to solve a right triangle, is to find all of the missing measurements, including angles and side lengths. So for this example, if this is our triangle, we are missing this side length AC and this side length CB. So that's what we're trying to find. Now, we are given the hypotenuse of this triangle, so what we're going to do is use some sort of trig identity to set up some sort of ratio so we can solve for our missing sides, or sometimes we have to use an inverse to solve for our missing angles, but either way it's some trig identity. And then at the end, an easier way to go about that is to use the Pythagorean theorem to solve for our third missing side length, although you could use trig identities for both of them or some sort of trig function. So for example, I could start here at this angle, so I could do, say, the sine of 56 and look for this missing side length. I'm just going to label it as B and label this as A, so this is across from my angle B and across from my angle A. So sine of 56 is going to be B over my hypotenuse of 12.7. And then to solve for B, we have to just multiply both sides by 12.7. So we get that 12.7 times the sine of 56 is B. And we can type that into our calculator. That's why we did the approximations yesterday. 12.7 times sine of 56 gives us about 10.53. And again, we could use Pythagorean theorems to find our missing length now. Like this would be a squared and our b squared is 10.53 squared equals 12.7 squared. Or we could set up a different trig identity. Either way, we'll get the same answer. So I'm getting that a squared is 50.4091, which means that A is 7.10 approximately. Okay? So again, it's not anything super new. We did this in geometry. You did it in Algebra 2. It's all right triangles that we're dealing with. And I'll tell you the angle that we're looking for. So our angle here, or I'll tell you the right angle so that way you can set up your triangle. So for example 2, we're given this triangle ABC. So I'm going to draw a picture, and I would always suggest that you do draw a picture because it makes your solving a little bit easier. So C is our 90-degree angle. This capital A is going to be our angle measurement, 24.9. And then A, across from A, is 4.6. So we need to find B and we need to find C. So we're looking for three things, B, C, and then angle B, to come up with solving our missing triangle. The angle B is actually pretty easy to find because I know that this angle is 24.9, and we already talked about how these two angles are complementary because this one's 90 degrees and all my angles in a triangle add up to 90. So to find angle B, we just have to find the complement of 24.9 to get our answer, which is 65.1 degrees. And then now that we have that angle measurement in our triangle, we can set up a trig ratio to get our other measurements. And I would actually use this one, might as well, to set up to find B, because our B then is going to be in the numerator. So if I'm dealing with like B and this side, this would be my opposite and my adjacent, which means I'm going to deal with tangent. So the tangent of 65.1 is equal to opposite over my adjacent. And then just like above, to solve for B, we have to multiply by 4.6 on both sides, and then that will give us our answer once we type it into our calculator. 4.6 times tangent of 65.1, and we should get 9.91 approximately for B. Okay, so then we solve for b, we got 9.91, so I'm going to put that again in my picture just so that I could use it if I wanted to. And now the last thing we have to do is solve for c. And again, you can use it, you can do it two different ways. One, we have our side lengths, our two side lengths, so we can solve for our hypotenuse using the Pythagorean theorem. We also could use a trig identity to solve for c, so I could do like the cosine of 65.1 is 4.6 over c, and then solve it that way. I think the Pythagorean theorem is easier, so to solve for our missing side length, we're going to do our b squared plus our a squared equals c squared. And if I solve for that real quick, 4.6 squared, square root, I get approximately 10.93. I'll just round it to 2 decimals. So there we go. Okay. Let's try another one. And you can actually pause it and try to set this one up too. See what you get. Oops. I need to label that as C. A and B. A value is 29.43. C value is 53.58. So in this case, when we're looking at this example, we are missing, oh, my cord's in the way. Hold on. There we go. We're missing 2 angles, angle A, angle B, and we're missing side length B. So 3 things that we're looking for. Last time we could solve for an angle really easily because we were given one of the angles, so we just had to find the complement. This time we're not given that. So in order to find an angle, we're going to have to use a trig substitution or a trig value to actually get there. And then since we're looking for an angle, remember if we are finding an angle, then we're going to use an inverse, angle inverse. So we can solve for B using the Pythagorean theorem. So if I do that real quick, I don't have to show all those steps hopefully, 29.43 squared, so we'll get 2004.6915, and then take the square root to get 44.77 for our side length B. As a general rule of thumb, when you're given like 2 decimal places, you should also round to 2 decimal places, but I'm not too particular on that. Should specify a little bit on rounding. And then to solve for angle B, we don't know, like we are going to use a trig ratio, and it doesn't really matter which one you do or which angle you're starting at. I'm just going to start here with angle B, and then I might as well use cosine because these are the 2 ones I'm given. It's a little bit more exact. So if I am standing here at angle B, I can set up the cosine of B is equal to my adjacent side, which is 29.43, over my opposite side, which is 53.58. And then to solve for angle B, since I have cosine in front, I have to undo it. So I have to take the inverse of both sides, which undoes cosine, and the opposite side will have the inverse cosine of the 29.43 over the 53.58. So inverse cosine 29.43 divided by 53.58, and we get an angle measurement of 56.68 degrees. And then now to solve for angle A, I'll do that right above, running out of room. But we could set up another trig ratio, like we could do sine of angle A is equal to 29.43 over 53.58, and then do the inverse sine of the 29.43 over 53.58. But we know that like the inverse sine of this is really just going to be the complement, because the cosine and the sine have from those different angles, like cosine of A equals sine of B, and so those things are complements. So we could just take the complement of this angle, and we get 33.31 or 32, I guess if we rounded it. correctly. But also, again, like I could do the inverse sine of 29.43 divided by 53.58 since, oops, if I could type it in right, because that's what this ratio would be from sine. It would be sine is equal to 29.43 over 53.58, and now I have to take the inverse, and we should end up with the exact same solution. So either way you set that up, don't make it harder on yourself necessarily. So like if you can use the Pythagorean theorem, use it because it's nice and easy. But if you can't, or if you can use the complement, like you might as well use it, but you can always check your answer a different way. Okay, so then the last little bit is looking at a story problem and developing with the angle of elevation and the angle of depression. The angle of elevation is the angle, and I'm going to make this as general as possible, is the angle looking up from a horizontal line. So if this is like my object in the air or something, and this is me standing on the ground, I have to draw this horizontal line, and it's the angle formed between the line of sight that I have looking up to the object and that horizontal line. The angle of depression is the angle looking down from a horizontal line. Between the line of sight and the angle looking down. So again, like let's say here I am at the top of this cliff, because that's usually kind of the situation. Here's some object down on the ground and I'm looking down to that. It's the angle looking down from the horizontal line. So just like the quadrants, how like this is really like the reference angle that we're looking for. Like, okay, so here's my quadrant 3, and here's the triangle that I'm formed. I'm really looking at that angle. That's really the reference angle that we're looking for too for our angle of depression. So you can kind of think about it that way. So this would be then like the theta that we're looking for. The triangle that we have is still from that like horizontal line of sight. Okay, so let's do a couple examples. Jack knows that he stands 123 feet from the base of a flagpole. So here he is. Here's my flagpole. He's standing 123 feet from that. The angle of elevation to the top is 26 degrees and 40 minutes. His eyes are 5.3 feet above the ground. So here's Jack standing 5.3 feet. And here's his horizontal line for the line of sight. And here's then the angle of elevation to the top of the flagpole. So that's the 26 degrees and 40 minutes. And we're trying to find the height of the flagpole. So we know that if we solve for this little piece here, since he's 5.3 feet above the ground, the height of the flagpole, this distance that we're actually looking for, is going to be x plus 5.3. Okay, but our triangle stands the same, where we're looking at like this right triangle. This is our angle. This is the adjacent side that we have. So I can set up a trig function for that. Like this is my opposite, this is my adjacent, which means I'm going to look for tangent. So tangent of 26 degrees and 40 minutes equals my opposite side over my adjacent side. And just like the front, we can solve for x by multiplying by 123 on both sides. So when I type that in, remember the degrees, minutes, seconds stuff. So 123 times tangent of 23 degrees, 40 minutes. And I get an answer of 53.91. So that means that my height, because so far I've just found from his eyes to the top of the flagpole, my height is going to be that plus Jack's height, which is 5.3. And I get 59.21 feet. Okay, we've done problems like that in geometry too, and algebra too, so you should be pretty familiar with this section. Same thing down here. We have this observer standing on the top of this cliff. So here we are on this cliff. He spots this house in the valley. The angle of depression. So here he is on the top. The angle of depression is 12 degrees. The cliff is 60 meters tall. We're looking for how far the house is from the base. So that's the angle that the value that we're looking for. The angle of depression, so from this person down to the house, is 12 degrees, but that's again not this angle. We have to form it kind of with our axes, so we have to have this horizontal line that's drawn out with the line of sight. So this angle here at the top is the 12 degrees. So our triangle that's formed, you can actually find the complement and then use this triangle to do that. Or we can draw a triangle on this side, which would be a congruent triangle since this is a rectangle. And so this still would be 60 meters tall, and this would be then the value that we're looking for. So either way you want to shake it, like you could find this one again and do 90 minus this and then come up with a triangle for that, or you can use this triangle off to the side. I'm going to use this one because why not? So here's my 12 degrees, so I'd be using my opposite side and my adjacent side, which is tangent. So tangent of 12 equals 60 over x. Now this one's harder to solve for because the variable's in the denominator, but I'm just going to make that tangent over 1 and then cross multiply. So I'll have x times the tangent of 12 equals 60 times 1, which is 60. And then we solve for x and we just divide by the tangent of 12. Remember, the tangent of an angle is just a ratio, it's just a number, so we're totally fine to do that. And divide by it. We can't divide by tangent of nothing, but we can divide by the tangent of some value because we know that that's a ratio. And we get an answer of 282.28. And this is in meters. Okay. So hopefully that section was hopefully this whole lesson was pretty easy. Again, the idea here is that from these triangles we can set up some sort of trig ratio either to find an angle or a missing side length, and then we can use a complement or the Pythagorean theorem to find those other missing things. And then the big idea for this back part, the angle of elevation, that's with that line of sight, so going straight out and then looking up, or with that line of sight going straight out and looking down. So they're kind of like the angle of elevation and the angle of depression are like alternate interior angles, if you remember that from geometry. This again is like my angle of elevation, and this would be my angle of depression up here at the top.